Hello again. In the last video I showed you how to create a simple model reflecting how you might log into a system with a simple login screen. In this video I want to look further into how you create test cases for a model. Now the way to look at it perhaps is to say that when you create the initial model, this gives you the structure of the flows through the system, the application. What I'm going to do now is add the test data and expected results to complete test cases using the structure you've already created. I'll use a simple discount calculator feature to show how we do this. Now the way it'll work is I'll create a new model from scratch and show you how that works, and then we'll use it to generate what's called default input data variables within ARD. And these are, if you like, the input data columns in a table of data and expected results. When we've done that, we can create the expected results for each of these input data rows, and from that we can generate the test cases. So I'll explain in summary how this kind of works overall, but the same technique can be used for any straightforward model. Now the requirement I want to use is a discount calculation, which is very simple, and you could regard it as a subset, as a fragment of a larger transaction. So for our purposes of creating our first real test case, it's adequate for our purposes. The requirement itself is whether a discount is calculated and how it is calculated, and it's on the basis of whether a client is a new or an existing customer, whether they have used a loyalty card for the purchase or not, and whether they have a coupon offering a discount. And we're not going to look at the actual calculation of the discount. We're just going to look at whether the three decisions that are made in the feature, whether they influence the discount calculation. So we'll just capture the information on whether a client is new or existing and so on, and then report that as an expected result. It's the same process if you were doing a real calculation. Okay, here we are in Agile Designer again, and I'm going to create a new model. And I'll call it Simple Discount. And I'll leave it at that. And in effect, the three fields that are checked, new customer, loyalty card, coupon, I'll create three decisions for these in turn. So the first one is new customer. I'll just create it simply like that. The second one is loyalty card. And the third one is coupon. I'll join these up. So I've created all the true branches, and I'll do the false branches too. Okay, so that's the model in effect in its totality. There are three decisions, so what we'd expect is 2 times 2 times 2 combinations, or 8 paths. So let's go into the Path Explorer and look at that. So now in Path Explorer, I'm going to use all possible paths to generate the test case, the maximum number, and we'd expect there to be 8 generated from the 3 combinations of decisions. So as expected, there are the 8 paths rather. And what we can do now is, if we save these, we can start associating test data with the 8 saved cases. So now if we go into test factory test data, we have no data there at the moment, but we can generate variables, columns if you like, in the test data table from the names of the decisions and the values that are generated. So if I use add defaults, it'll suggest that I create test data variables for all the elements in the model. I only have decision blocks, and there are 3 of them, so we'll say yes to all that. So here we have the 3 variables, coupon, loyalty card and new customer, with the 8 combinations of values, true, false, true, false, true, false. So far so good. But what we don't have is an expected result column. And we create that by going into the element properties and looking at output details, and we create an expected result for each of the true outcomes of the 3 decisions. So if this is a new customer, let's say the requirement says the new customer discount applies, okay, and we're not going to bother with the false branch because the discount doesn't apply, so we won't say it doesn't apply, we'll just say nothing. We'll do the same for the loyalty card. Output details, the true branch, add an outcome, okay, and now we'll look at coupons, output details, true branch, outcome, and the coupon discount applies. We'll save that. So now if we go into data, you'll see we actually get expected results. So where we have a coupon, a loyalty card and a new customer, everything true, we get the new customer discount applies, loyalty card discount applies, coupon discount applies. And where we have 3 false branches, nothing. And if we look at, say, this one here, where we have only new customer, you see the new customer discount applies as an expected result. So now we have, in effect, a sort of complete test cases where we have the path defined by the flow name here. Each test case, each path is given a test name, which is unique. We have our input data and we have expected results. So we have pretty much everything we need to generate a test case. One last thing I want to show you is we can export these test data values to, in this case, a CSV file. And I can save this. If that's an old one there, I'll overwrite it. Okay, so now I should have in my desktop a simple discount unresolved.csv, which I'll open, and you can see the test cases here. So in principle this could be given to a tester or imported into your test management tool if you wanted to do so. I won't save. Okay, so that's how you add test data expected results to generate completed test cases. So let's just summarize what we've done here. When you create a new model, you're creating, in effect, the structure of a test case, the path through the model itself. And in order to complete the test case, you need to create the test data variables and data values, which can be done for you, and then we append expected results to complete the test case. In our case that we just saw, we create an expected result only for the true outcomes. You could easily, of course, create expected outcomes for the false values of the 3 decisions. So the expected results are triggered at the level of each decision outcome. Now, where expected results are triggered by combinations of multiple decisions, we need to take a slightly different approach. These scenarios are often described in decision tables in a more compact way, and we'll look how decision tables can be modelled in a later video.